So in the previous lesson, you guys were talking about something called nature of the roots. And basically what nature of the roots deals with is it deals with this part inside of the quadratic equation that we call delta. And if we work out what delta is, we actually don't need to know the answers to the equations to classify the roots, just to know some information about them. And what you would have learned about is that if delta is negative, the roots are non-real. If delta is 0, the roots are real, they are rational, and they are equal. And then the last category, if delta is greater than 0, they're going to be real and different. But if delta is a perfect square, the roots are rational. And if delta is not a perfect square, then the roots will be irrational. So let's just do a little warm-up. If delta was 25, tell me about the roots of an equation. So assuming I've got this equation, I've worked out delta, I want to know in the chat, how would you classify the roots of that equation? No, so it's going to be real, yeah, because delta is greater than naught. It's going to be rational because delta is a perfect square, and it's going to be unequal because of the fact that delta is not 0. And I'll just show you quickly why this works like it does. If you imagine that the quadratic formula can be written in a shorter form like this, where instead of b squared minus 4ac, we have delta. If we have delta being 0, so if delta was 0, then the plus minus has no effect, okay? Because square root of 0 is 0, plus or minus 0 is nothing. There's no effect. And what happens then is you have two identical roots. They're just going to be minus b over 2a. If delta is 25, then what's going to happen is, or if delta is a perfect square, you have minus b plus 5 over 2a, or you have x is minus b minus 5 over 2a. And so you have two different roots, but they're going to be rational because they're going to be in the form a number over a number. If delta was not a perfect square, so let's say, what's a number that's not a perfect square? Let's say 17. 17, when it's square rooted, is going to be irrational. And so that causes both of the roots, the plus and minus root, to be irrational. And so that's why this perfect square, not perfect square thing comes into play. So can you give me a thumbs up if the value of delta and its relationship to the types of roots we have makes sense to you? Give me a thumbs down if you don't understand this relationship, because it's important going forward. I have a sense of what the class feels like they know. We can do one more just to check. Oh, in fact, I tell you what, let's do a practice one here. I want you to tell me what the nature of the roots are without solving this equation, a g. So off you go. Here is an equation. I don't want you to solve it, but I want you to classify the nature of the roots by finding delta. And then we'll check if your understanding is kind of how it is. What do we think delta is? So it looks to me like delta is minus 851. Now, what does that mean about the roots of the equation? Okay, so they're going to be non-real, huh? So we don't actually have to include the not equal thing at this level, at sort of school level, but basically we can say they're going to be non-real now. So the roots are non-real, and that's because delta is less than 0. Okay, that wasn't so bad. Okay, well, let's do another one, but I think you guys have got the basic ones down. Let's do J quickly. Tell me about the nature of the roots of J. Without solving the equation, what are the nature of these roots? Get rid of that one for now. Again, we're not solving the equation, even though it would be easy here. We're simply classifying the nature of the roots. Now, what would B be here? This is a bit tricky. B doesn't exist, so B is 0, yes. And this would be 1, and this would be minus 4. So delta would be 16. So what are the roots? The roots are real, they are rational, and they are unequal. So real, rational, and unequal. Because the real part is for delta just being greater than or equal to 0. This part is when you have a perfect square, and this one is when it's greater than 0. Yeah. Okay, I think I need to make life a bit tougher for you. So, being the good teacher I am, hopefully I'm prepared to take it up a notch. So, here we go. I want you to tell me what is the nature of the roots of B, the yellow one I just cut it in. Find me the nature of the roots of this one without solving the equation. And if there's a question, I would love to hear it from the students of the class. Otherwise, you can get going. If somebody's feeling generous, maybe they can give us a tip as to how they think. What's your strategy? How would you approach this question? If you're feeling generous, pop it in the chat or raise your hand and you can let us know. I'm sure some students would appreciate some help. Obile, foil first. Obile, I like your thinking. I'm thinking that the foiling or the multiplying out will clear up some of the mess. I think you're onto something there. Yeah. That's a top tip from Obile. And Manda is even looking ahead. We are going to do C next. You're quite right, Manda. I think you seem to be on top of your game today. So the top tip I'm going to recommend is multiplying out first, and then think about what do you have to do in order to work out delta. This is something that you always have to make sure of. And for the new students, we did do a lesson on this in the previous lesson on Monday. So if you are feeling a bit unsure, don't worry. And you're quite welcome to ask questions to kind of catch up if you'd like, either in the chat or put your hand up and we'll take an audio question. Fatejo, indeed, we want to put this in standard form. That will help a lot. Let me see if I can do my multiplying out first. So there's my multiplying out. And then I want to put it into standard form. I think that's my standard form. But now I actually need to find delta as well. And then once I know what delta is, I can hopefully work out how to classify the nature of the roots. Ah, Shante. I'm not sure what the answer is yet, Shante, but it looks suspiciously like you're on the right track. Although, let me do my homework first. We have to watch out for these substitutions that we don't make a silly mistake. Yes, because of -4 times a -12, I get delta as 64. Now, if delta is 64, how would I classify my roots? So Gabrielle, I think I agree with you. So because delta is greater than 0, the roots are real. They are rational because of a perfect square, and they are unequal because it's not 0. Yeah. Oh, my screen just flicked into dark mode. Let me disable that. Okay, I want everyone to now attempt C. I want you to classify the nature of the roots of C, or the question in pink, and I want you to try and use some of the ideas that you just applied in this question now. Again, I do encourage you guys. I promise I don't bite. I try to my best to be friendly. You're more than welcome to ask a question, but otherwise just get moving on the pink question. But yeah, especially for my new students, I know that this must be quite a lot. And so feel free to put your hand up and we can have a chat. Okay, so how do you find if it's rational or irrational? So Caitlin, this goes to whether or not delta is a perfect square. So in the last one, because delta was a perfect square, it was 64, we would say that it is rational. But if delta in the previous question was 63, it would then be irrational because 63 is not a perfect square, but it is still a real, because the real roots are real when delta is either greater than or equal to 0. And so both of these values, 63 and 64, are both greater than or equal to 0. So they are real. And basically, we're looking for the perfect square. Okay. And then the only time roots are equal is when delta is 0. And so that's not happening here. No problem, Connor. What I would recommend is you can have a look at the load shedding, the video recording after, and you can fill in the bits that you are missing. Cool. Thank you for your question, Caitlin. I do hope that was helpful. So there was a good tip about how to handle the pink one earlier. I wonder if anybody else has spotted it. How do I get my life organized how do I unclutter my life for C? What's the key thing I need to do? Yeah, you need to multiply it out or use the LCD. Exactly. Yeah, that's what you need to do. So I'll give you some time to do that. And I clear some space. I'll write it out again. yeah, you cross multiply is another way of saying it. It's you basically want to deal with this bit at the bottom. And if it's divide on the side, it'll be times on the other side. Well, there's still quite a bit of work to do, but I leave it to you guys to try and classify the roots for C. Keep those answers coming. We have so my standard form is 4x squared minus 6x plus 1. But I still need to figure out what delta is in order to classify those roots. So I'd like, yeah, I'm going to wait a bit longer and see what the class is coming to. Or if somebody wants to come online and tell me how they did this last bit, that would also be cool if you feel comfortable to do that. Yeah. So Andile has given an answer. Shante has given an answer. Kevin's given an answer. What are the other students thinking of right now? I know I need to figure out what delta is. Okay, Melissa. What do I get as my... Now, did I make a mistake? Let's have a quick look. 4x squared plus 2x plus 1. So that's 8x squared minus 4x plus 2. Then I get minus 6x plus 1, 0. That's fine. 36 minus 4 times A times C. So then I get 20, or I get 36 minus 16, which is 20. And so, yes, let's go to Manda. Manda, what's your answer? How would you describe the roots?
Hi.
Can you hear me, Manda?
Yes, I can hear you. Can you hear me?
Loud and clear.
Oh, hi to everyone. I would describe the roots as real irrational roots, but then I just wanted you to hello.
Yeah.
I just wanted you to repeat the part where you started writing by blue on the question.
When I started there, what part would you like me to repeat? I don't know if you can hear me, Manda. Maybe just pop it in the chat.
Hello?
Yes. What part would you like me to repeat? Okay, I think maybe we just had a little the part where you started writing in blue.
Start by when you did the blue steps.
The blue part. Okay.
Well, you started writing by the blue part there. When you cancel, I don't really get it.
Okay, perfect. I know exactly where to help you. So you'll notice at the bottom here, there is this...
I was just saying...
Okay. It's fine. We got you. I think there's a bit of a lag with the thing. All good. So this comes across here, and we get that. And then we simply multiply this into here to get all of those pieces. And then the last bit, I'm saying, well, if I bring the 4 across, I go 8 minus 4 gives me this bit. And then the 2x on this side comes across with this, and I get minus 6x. and then 1 on this side comes across, becomes minus, and then 2, and I get this. So roots are real, irrational, and unequal. And I just wanted to get it all on one side. Okay, so I hope that was helpful there. All right, we are going to squeeze in one more type of question, but a different type of question. Ipeleng, my substitution was different, but I came to delta of 20. That should be fine then, I think. Okay, here's a different type of question. And I want to ask, before we go to our break here, what is different about this last type of question? For which values of k are the roots x squared plus 2x plus k real? Who would like to give me some feedback, some audible feedback, or some feedback in the chat? What's different about this type of question? It is a different type of question. So C is a variable. It's like normally in the past, we were given like a 3 or 5. Now we have a variable K. And the question says, for which values of K are the roots real? Okay, now here's the thing. For real, let's talk about delta. For delta to have real roots, what does delta have to be? Like if delta is -3, are the roots real? No, they're not. If delta was 0, then the roots are real. And if delta is like bigger, if delta is like 13, the roots are real. So one of the important things here is we need to make sure that delta is greater than or equal to 0. Oh, Paul, we are on the same page. Now, the problem is we need to work out what delta is, but we need to work out what delta is in terms of k. So can I set you that task? I want you to work out what is delta for this quadratic equation, but your answer will have a k in it. So work it out for me. What is delta in this particular situation? Okay, Masana. So if I had to ask you, let me put it like this. What is A, what is B, what is C in this equation? This one that I've just, if I had to ask you to write down a value for A, I think you would tell me that A is 1. And if I asked you what B was, B would be 2. But then C would have to be K. And that's what's new here. Now, using the idea of delta, I go b squared minus 4 times a times c. But what's different here is I'm going to have that calculation. And so this is what I'm asking. What is delta going to be in terms of k? And it looks like Obile and Kosi, Osisiwe are all saying it's 4 minus 4k. All right. So we know that delta for this one is 4 minus 4k. We also know that for the roots to be real, delta must be greater than or equal to 0. Who would like to tell me how I put these two worlds together? I know there's someone out there who has an idea, and I want to know. So used to the lights being off that I forgot that I could turn my lights back on. So how are we have to answer this question. And I think the way we're going to do this is we say 4 minus 4k, which is delta, must be greater than or equal to 0. If we can solve this inequality, and we did inequalities last week, if you can solve this inequality, you can get me the right answer. So I want you to try and get me an answer before we have our break. How would we solve this inequality? So I found delta. So step 1 was to find delta. Step 2 was to know delta had to be greater than or equal to 0. And step 3 is now I have to solve this inequality. Which answer is going to be correct? A, B, C, or D? I think from last week when I was doing inequalities, although it's not the only way to do it, I was going to move the minus 4k to the other side. And if I did that, I should get 4 is greater than or equal to 4k. Now, some of you will say, no, Mr. S, you need to switch these inequalities around, but you don't. And the reason you don't is I just moved the term from one side to the other. I haven't divided by a negative. And now in the next step, I'm going to divide both sides by 4. And when I do that, I'm left with a 1 on this side. And on this side, I'm left with a k. So now I have to ask myself, which of the 4 options have k as less than or equal to 1? Rawaka, I'm going to come to you now. So the crocodile mouth is going to the 1, the little side is going to the k. And so I think the correct answer should be A. Now that was a toughie, and I can see why some of you chose C, but just have a careful look at that all over again and see if you understand what I was. Okay, let's go to questions. Let's go to Cass initially, and then I think there was another student who also had a question. Cass, what's your question?
Hey, sir. So,
Hi.
I moved over the 4 to the right
Okay.
side. So it became -4. Now,
Okay.
if I divide the -4k by the -4 on the other side, would the signs not change?
Okay, they would. So what you did is completely fine. You just have to adjust. So let me show you your way. So from what you're saying, you did this. Is that correct, Cass?
Yeah.
Okay. So all is well, but the only difficult thing now, or not difficult, is you need to divide by -4 on both sides. And when you divide by a negative, you have to switch the direction the crocodile mouth is facing. So now, can you see how it's facing the other way? And
Yeah,
so this becomes k, and this is 1.
Okay, I see.
And so you see now that the sort of greedy mouth is facing to the one side, and the sort of smaller side is still k. It just they're written on opposite sides, but they've been switched as well. So the answer is still A, even in your method.
Okay, thank you, sir.
Cool. And let's go to Oratile. Oratile, what's your question?
Evening, sir.
Hey.
So, sir, I'm really struggling to understand how we were proving that the whole equation was equal to for which values are the roots
Yes.
of the equation going to be real?
Yeah. No, it's quite abstract. So let me just quickly go from the most important point is, do you agree that if delta is greater than or equal to 0, the roots are real? Like if you think earlier in the lesson, like if delta was -5, the roots are non-real.
Yes.
If delta was 0, the roots are real and they're identical. If delta was 27, they would be irrational, but also real, right? So we're really focusing on the real part. And so I need to check with you, are you happy that delta being greater than or equal to 0 is the roots are real?
Yes.
Okay, now, are you happy that delta is 4 minus 4k? Are you happy with that calculation?
Yes.
Okay, so what I'm going to do is I'm going to put these two worlds together. So here's a delta and here's a delta. And so I go 4 minus 4k is greater than or equal to 0. So in order to figure out what values of k make delta greater than 0 and ultimately make the roots real, I have to solve this inequality. And that's what I was doing in those two different ways that I did. Does that make a little bit more sense? The way that I did initially was I moved the 4k to the other side, and then I divided by 4, and I got 1 is greater than or equal to k.
Yes, I do understand how you went about that. Yes,
awesome.
sir.
Fantastic. This is why I like Zoom, because it's easy to have the conversation. Okay. Manda, I see you have a question, and then we will take our break. We are due a nice stretch. Manda, what is your question? Don't know if you can, your hand is up.
Hello, sir. Can you hear
Hey,
me?
loud
Am I
and clear.
audible this time? Okay.
You are perfectly
So,
audible here.
so what I wanted to ask is that you see when you divide by the 4, I heard
Yes.
sometimes that letter sign, the greater and the less than sign, it sometimes switches its sides. So that's what I wanted to know too.
Okay, very good question. It only switches if you are dividing by a negative or if you are multiplying by a negative. In this method that I just did, I only divided by 4, in which case it still faces the same way around. If I was dividing by a negative, like I was talking to Cass about now, then I would switch it. And I will still get the correct answer. Okay.
Okay.
So
Yeah, I see.
cool. And we'll come back to that later in the lesson. Okay, it is brain break time. So what I want everyone on their feet, and I want the cameras on so I can see the wonderful students that are in my class and are working hard on a Wednesday evening to get better at maths. And we are going to have some fun together. So I want you to just roll those shoulders, feel that tension melt away, and just do 5 rolls of your shoulders back. And then we can roll your shoulders forward. There we go. Then stretch your neck to the one side. 1, 2, 3, 4, 5. Stretch to the other side. And then swing your arms nice and loose. Look out in front of you, head in front. Okay. And then we can twist our bodies a little bit. Initially, not too far. And then as you relax, you'll find that your hips kind of swivel further around. And you might hear some nice clicking sounds too, if you're lucky. Oh, I'm hearing the clicking sounds. Okay. Then what I want to do is I want to do my pen flipping exercise. So make sure that you are clear that there's no cups of coffee or anything that you can spill over, and you've got a pen or something in your hand that's relatively heavy. And the goal tonight is to go with your opposite hand. So if you're right-handed, you use your left hand. If you're left-handed, you use your right hand. And you hold it on one end, and the goal is to throw it up and so that it spins in the air once, and you catch it on the same end. I'll try and demonstrate. There we go, I did it. It only spun once. Ah, that was bad. Okay, see if you can do it. There we go, I got it right. Somehow I'm better with my left hand. There we go, I'm nailing it today. Look at that. Geez, I should go to work in the circus. Here we go. All right. Now, it does help if your pen is heavier. That's what I've noticed. All right. One more thing. So I think it was Emmanuel who suggested this high heart rate exercise. I'm open to other suggestions. He suggested what we call air skipping. And so we're basically going to do this motion, and we're going to do 25 air skips. And we're going to get our heart rate up so the blood is pumping in our body. Okay. 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25. And that is our high heart rate activity. So thank you to Emmanuel. That was a lovely suggestion. Get your suggestions to me for the next lesson. And then let's do a quick little Maths 24 puzzle. Can you solve these Maths 24 questions? You know the rules of the game. If you knew, you probably don't, but you have to use all 4 numbers on a card to make 24 using only plus, minus, times, and divide and brackets. So let's see if we can do that. Let me see if I can look at the chat quickly. Oh, where to? Let's have a look if I agree with you. So 5 times 3 plus 4 plus 5. 5, 3, 4, 5. Yes, I agree with you. And Nkosi has another way of doing it. 5 times 5 minus 4 minus 3 with brackets around these two, which will also give you 24. And Teboho agrees, and Tokozo agrees. Tendai also agrees. Okay, so the red one we have mastered. Gabriel agrees. What about the second, the blue one? Can you master the blue one? Can you find 24? Probably not a bad decision if it is hurting your brain, blinds your eyes. So Andile, what have you said here? You said 5 times 4 plus 8. 5 times 4. How did you get your 5? Oh, you added 4 and 1. So 4 plus 1. So 5 times 4. But you've used up your 4s already there. So Siabonga, 8 plus 4. So 4 times 1 times 4. Oh, yes. Okay. Siabonga, I see what you've done. So you've just said 4 times 4 times 1 is 16. And then plus 8 gets me to 24.
Nicely done, guys.
And then just see where, yeah, this is see where it has a very similar way of doing it. In fact, and then, oh, that's interesting. 8 minus 1. I'm going to come up with different ways. 8 minus 1 is 7. And then 7 times 4 is 28. And then minus 4 is 24. Yeah. Okay, cool. I definitely notice as a group you're getting quite strong at this Maths 24. I think I'm going to need to bring the yellow ones back to keep it entertaining. The 3 dots. Okay, let's go back to the second half for the last bit of this lesson. And we're going to do some what I call interpretation questions. So these are going to look a little bit more wordy and we might have to clarify what's going on. But let's try them anyway. So it says the solutions to a quadratic equation are x is 5 plus or minus 10 plus 2a. For what values of a, will the equation have equal roots? So I want you to think what delta needs to be for equal roots. And I also want you to think about what delta might be based on this thing here. And let's see what answers you can come up with while I talk to Sibiso. Can you hear me? Sibiso? See your hand is up. Can you hear me? Hey, how's it going? Can you hear me? So I think maybe we have some audio problems. So for equal roots, delta has to be equal to 0. That's the only way. If you go back to the quadratic formula, the only way you can have equal roots is if basically this part here doesn't matter. If the plus minus of 0 doesn't matter, then the roots are both minus b over 2a. So you know delta has to be equal to 0. The other thing is that because this is a quadratic equation with roots, you also know that delta is going to be 10 plus 2a. Now, can you bring those two pieces together? What does A, for what values of A will the equation have equal roots? So Siyabonga, only if they say equal roots. So for equal roots, delta has to be 0, yes. So what we would say now is we say, well, this has to be true so A has to be equal to 0 in order for the roots to be equal. So now I have to solve for A. And so you should get A is -5. Give me a thumbs up if you can follow my argument. Give me a thumbs down if you feel a bit like I've gone to the abstract, too abstract. Okay. It's a mixture, but I think the best thing we can do is take a screenshot or come back to this example again later. I'm going to try and squeeze in a couple more. Oh, good question, Fola. So the 5 isn't involved because this is already in the form. Delta is only the thing inside the square root. So that's where I just took delta from inside the square root. Okay. So that's where I pulled this bit from. Okay. So let's go with let's go for a question that's quite similar. Determine the nature. Okay, let me choose one that will be suitable. Okay, let's just try this one. So to start with, and I know there's lots of letters and so that causes a bit of panic, but let's just think through it slowly and carefully. So it says, if b squared minus 4ac, which we know is delta. So if delta equals 7k squared, determine the nature of the roots if k is 0. So the question is telling us that delta is 7k squared, but that k is 0. I want to know what are the nature of the roots for this equation in this scenario. So what does delta have to be? Delta has to be 0. So what does that mean about my roots? They are going to be real, they are going to be rational, and they are going to be equal. Because 0 is also considered a perfect square. It's a weird perfect square, but it is a perfect square. Okay, now, using that same type of question, I want you to do the case where k is root 7. What are the nature of the roots for b? So I know that delta is 7k squared, but k is root 7. So what are b's nature of the roots? It feels like most people are agreeing with me that delta should be 49. So how do we interpret that? Toboho, Siyabonga. So it's going to be real. It's going to be rational. And it's going to be unequal. The reason it's real is delta is greater than 0. The reason it's rational is delta is a perfect square. And the reason it's unequal is delta is greater than 0. Let's just do a quick check. Thumbs up if we're feeling okay with this. Thumbs down if we're feeling a bit like it got a bit too abstract. Quick little vote and keep those honest things coming in. Let's try and squeeze in one more question because you're doing well. So I want to challenge you. I don't want to. I want you to see all the different types of questions. And so let's probably finish with this last one here, where we can work through it first together. So let me talk through it, and then we can start trying to solve it. Calculate the value or values of P for which the equation has real roots. Let me get my yellow. Calculate the values of P for which the equation 2px squared minus 4 plus 3 equals 0 has real roots. And then hence find one value for P where the roots will be real and rational. Now that's almost like a second part. So I'm going to put that in green. Now, in this topic, even if the questions sound really weird and wonderful, what do we almost always seem to end up doing? So what do you think my first step is going to be? Yeah, find delta. You're absolutely correct. So if you find delta, that's half the battle won already. So I want everyone to try and find delta now using this over here. So Siyabonga, we do have all the topics on the website for you to look through in terms of other types of topics. And then next week, Monday, we start an analytical geometry. What topic are you currently doing, Siyabonga, at school? So what is my delta value going to be for this? Okay, so yeah, Siyabonga, we start analytical geometry on Monday. And so we'll definitely deal with that going forward. So let's have a look. What can we put here? So B is minus 4, A is 2P, and C is 3. So delta would be 16 minus 24P. And this is the toughie, so that's why we're ending with this one. Now, if we are thinking delta has real roots, what do we know about delta? Someone can tell me in the chat, what does delta have to be if delta has real roots? Not just 0, so delta can be greater than or equal to 0. We did a question a little bit like this earlier in the lesson. So I'd love someone to come on and share their thinking. How do I bring these two pieces of information together? I'm really keen to hear from a student as to how I go about bringing these two worlds together. Who feels lucky? So we have to find a way, solve it like inequalities. Yeah, Melissa, so here what we do is we go, we know that 16 minus 24p is delta, and we know that delta must be greater than or equal to 0. So using the idea that I showed you earlier in the lesson, can you solve for what P must be? I want everyone to have a go at this. We had a nice discussion about this. No problem, Veda. You can catch on with the recording. It will be helpful to you. So if I bring this to that side, and then I divide both sides by 24, it feels like this should be 2/3, and this should be P. And so in order for the roots to be real, P has to be less than or equal to 2/3. Okay, so P has to be less than or equal to 2/3. So that's good news. Now, once we realize that P can be multiple values, right? So P could be 2/3, P could be 0, P could be -1. Let's just check a couple of values. So P could be, it could be 2/3, or it could be 0, or P could be -1, because -1 is less than 2/3. The second bit of the question where it says, hence, find one value for P where the roots will be real and rational. Oh, wait, I've got to be careful here. It says real and rational. So I would like from the class, what value of P will be real and rational? I want some, this is a great question. Unfortunately, I was looking at just being real, but now I have to be rational as well. It has to be a perfect square, Fatehwa says. Okay, but it can't just be any perfect square. It has to be one that is less than or equal to 2/3. So I think the only perfect square can't be 1. Okay, so what's the only P value that could, well, actually, you could get different perfect squares because, okay, the fractions, but I was thinking P could be 0, would be a perfect square, or another perfect square is a quarter, because a half times a half, but that's sneaky, because a half is less than 2/3, and a half times a half gives a quarter. But two of the options that I can think of would either be P is 0 or P is a quarter, and I can see a lot of you went for 0. Okay, that was a toughie. That was like a proper, like 80% question there. All right, everyone. That is a pretty solid session on nature of the roots and inequalities and these types of things. Lebo, if I could ask you to put the link to this week's quiz in the chat stream, please make sure that you either complete that quiz tonight or by the latest by tomorrow afternoon, evening. And on Monday, we will start with a lesson on, or we start with a series of 6 lessons on analytical geometry. Okay, and so unless any further questions, that is tonight's lesson. I do hope you enjoyed it. But if there are any final questions, I'm happy to have a go at trying to assist you now. So just let me know. Otherwise, also welcome to our new students. I hope that was an enjoyable first session, and it'll be great starting from Monday when you start at the beginning of a topic. That will make life much easier for you. And thank you to Lebo for toughing it through, because Lebo had a cold today, so she was powering through.
Always a pleasure, Mr.
Yeah. Are there any final questions, everyone? Otherwise, once you've got the link to the quiz, yeah, then you can go off to the rest of your evening. I hope that it's a pleasant one, and I will see you on Monday. And I did tell you about Watobe will be advertising the exam prep sessions, so watch out for those. And yeah, just keep working hard, work consistently, and yeah, success will come your way. All right, then that is it.
Guys, bye everyone.
Onka, we did circle geometry. Yes, if you look at the website, you'll see that there are circle geometry lessons there. Just have a look at the website and you'll see it.